Section 10-4, Surface Area of Prisms and Cylinders. The objective of this lesson is to learn and apply the formula for the surface area of a prism and a cylinder. Okay, let's go ahead and cover some few vocabulary terms first. Lateral face is a face of a prism or a pyramid that is not a base. So when you look at prisms, they have parallel bases. So for example, here we have a triangular prism, which has triangles as its bases. And the lateral faces would be all these rectangles around it. So your lateral faces are never a base. A lateral edge is the edge of a prism or a pyramid that's not a base. So these right here, going up and down, are your lateral edges. A right prism is a prism whose lateral faces are all rectangles. Okay, so these guys right here, if you look at this lateral face, they create these right angles, so we know that these are rectangles. And then an oblique prism is a prism that has at least one non-rectangular lateral face. So if you look at these shapes right here, our non-rectangular oblique prisms are usually tilted. Okay, so these are no longer right angles here on the corners. The altitude of a prism is a segment with its endpoints on the planes of the bases, so right here, that is perpendicular to the planes of the bases. So both at top and bottom, they're perpendicular. This is your altitude. You may also know it as the height, so how tall that prism is. So the height of a three-dimensional figure is the length of the altitude. The surface area is the total area of all the faces and curved faces of a three-dimensional figure. So it's the area of all the surfaces. So if you look at your prisms, we have different surfaces. Here we have rectangles and then triangles on the bases. If we looked at a cube, we'd want to find the area of all of these faces, all of these squares. Okay. Now the lateral area, that's just the sum of the area of the lateral faces of a prism or pyramid, or the area of the lateral surface of a cylinder. So lateral area, this right here does not include the bases. So if I looked at this prism right here, I would not include this triangle or the area of this triangle. Okay, the lateral area is just the area of all the lateral sides. Okay, let's take a look at the equations here. It says the lateral area of a right prism, so this is an example of a right prism, with base perimeter P, notice this is uppercase P, and height H is, so the lateral area is equal to the base perimeter times the height. So basically we would just find the perimeter all the way around here, and then multiply it by the height. That would give me the lateral area. For the surface area of a right prism with lateral area L, so capital L stands for lateral area, and base area, uppercase B, so uppercase B stands for base area, is equal to this equation right here, and I'm actually going to use this equation right here. Notice capital L is right here. So all they did is they plugged it in right here for L. So I'm going to use this one. So my surface area, S, is equal to the lateral area plus 2 times the area of the base. Okay, so capital B stands for area of the base. It does not just stand for base. It means the area of whatever that base shape is in your prism. Okay, example 2, find the lateral area and surface area of the right rectangular prism. Round to the nearest tenth if necessary. Okay, we've got a prism again. So first, let's go ahead and find the lateral area. I'm going to use LA for lateral area. The equation for that is the perimeter of the base times the height. Now, if you look at your prisms, your bases will always be parallel to each other, and there will be two shapes. So if we look here, my bases are my triangles. Here's one triangle, here's the other triangle. So those are my bases. And looking at that, I have to find the perimeter of the base. So the perimeter is all the way around this triangle. I know this side here is 20. I know that this side here is 15, but I don't know this side right here. Now if you notice here we have a right triangle, so I can do Pythagorean theorem to find the length of this side. Okay, so now we can find the perimeter here. So 20 plus 25 plus 15 is equal to 60. So my perimeter is 60. And now I'm going to multiply that by the height of my prism. Now, your height isn't always from where the bottom is to the top if you're looking just straight at this picture. Remember, the height is from one base to the other base. So from this triangle to the other triangle. So coming from here to there, this right here is your height. So the height of this prism is 25. Okay, so now we have all the information we need. We're going to do 60 times 25, which equals 1500. Okay, now we're going to do surface area. I'm going to put SA for surface area. So the equation for this is the lateral area plus 2 times the area of the base. Okay, well, remember my base is a triangle. So to find the area of the base, since it's a triangle in this prism right here, we have to use the area of a triangle. So area of a triangle is 1/2 times your base. I'm going to use 20 for the base of the triangle, times the height of the triangle. So 1/2 times 20 times 15, that'll give me B, the area of the base. Okay, so when you do that, we get 150, and that is capital B, the area of the base. We now have everything we need. Let's go ahead and plug it in. We got this, the perimeter base times the height. We got that from the lateral area. So I'm going to plug that in here. Plus 2 times the area of the base, which we figured out was 150. Okay, so then we just plug that in, and we get 1800. Okay, now we're going to cover the vocabulary for cylinders. We have the lateral surface, which is the curved surface of the cylinder or cone. Okay, so lateral is everything around. Remember, lateral means not the bases. Okay, so everything that's not a base. The axis of a cylinder is the segment with endpoints at the center of the two bases. So this right here, if you look for the center of both of your bases and you find that line right there, that's your axis. Same thing right here. Find the center of those circles, or of the two bases. A right cylinder is a cylinder whose axis is perpendicular to its base. So if this axis is perpendicular, then you can say this is a right cylinder. An oblique cylinder is a cylinder whose axis is not perpendicular to the bases. So right here you can look at it as a tilted cylinder. Okay, this axis does not form a right angle with the bases. Okay, so let's go ahead and look at the formulas. The lateral area of a right cylinder with radius r and height h is L equals 2 times pi times your radius times the height. The surface area of a right cylinder with lateral area L and base area B, notice uppercase L, uppercase B, is L plus 2 times B. But remember, L is equal to 2 pi RH, okay? Plus, this time we're adding 2 times, notice pi r squared, that's the area of the circles. Okay, let's go ahead and work through some problems so we see how we use this. It says, find the lateral area and surface area of the right cylinder. Give your answer in terms of pi. So first off, let's do lateral area. 2 and pi is just 2 pi. Now remember, it says leave in terms of pi, so when we solve this, we're going to leave pi alone. The radius is 8, and the height of my cylinder is 10. Okay, so let's plug this in. We're going to do 2 times 8 times 10, which is 160. Pi, we're going to leave it in terms of pi, so he's just going to tag along. And this is area, so it's inches squared. Next, for surface area, we know this part right here, we had 160 pi. And we're going to leave this one in terms of pi as well. So 2 times pi, my radius once again here is 8 from the problem that we just talked about, squared. So we're just going to add all this, leave the pi alone. At the end, your answer is going to have a pi. Okay, example 4, find the surface area of the composite figure, round to the nearest tenth. Okay, so this is asking for a total of both of these surface areas put together. So first off, let's take care of the cylinder. Now, if you look at your cylinder, not everything is included. This bottom portion of the cylinder is not included in the surface area. So you've got to be careful and not just use the surface area equation. Okay, you've got to notice that you have one base that is missing. So normally the equation for your surface area of a cylinder is 2 pi times the radius times the height plus 2 pi r squared. So notice this is 2 areas of a circle. I don't want 2 areas of a circle. I only want one of them. So instead of this 2, I can get rid of it and just leave the problem like that. Or you could find the area of that circle and subtract it later on, however you'd like to do it. So let's do this first. We know that the radius is 3 and that the height is 4. I can plug this over here as well. The radius is 3, and we're going to square this. So when we plug this in, now notice it says round to the nearest tenth. You do want to include pi, okay, so don't leave it in terms of pi. So here we get 103.7. Okay, so this is for my cylinder. Now down here I have a prism, and we're going to say that this rectangle up here and up here are the bases. And the equation for surface area of a prism was the perimeter of the base times the height plus 2 times the area of the bases. So the perimeter of the base, this is my base right here. So 9 plus 5 plus 9 plus 5 is 28. The height of my prism is 6. And then 2 times the area of the base, so 9 times 5 is 45. Okay, so 28 times 6 plus 2 times 45 gives me 258. Okay, now you've got to be careful here, because normally a lot of you would add these right here and then get your final answer. Surface area is what's on the surface. If I look at this prism, not every single part of it is showing to the surface. Notice this cylinder is covering up a circular portion of my prism. So I have to subtract the area of this circle once again. Okay, I subtracted it because of the cylinder. Now I have to subtract that area as well because it's not showing as part of the surface of my prism. So let's go ahead and find the area of this circle and subtract that from the surface area of the prism. So the area of that circle, pi times the radius, which is 3 squared. 3 squared is 9, and then 9 times pi is 28.3. So we want to subtract that from this number, the surface area of the prism. So 258 minus 28.3 is equal to 229.7. So I want to add this with this, and that'll be my total surface area of the composite figure. So 103.7 plus 229.7 is 333.4. This is the total surface area of the composite figure.